Hey everyone, have you ever wondered what if every yes became no? Imagine a machine whose only job is to do the exact opposite of what you say. You say on, it says off. You say happy, it says sad. You say close the door and it says nope, just like your brother. Well, this machine is nothing but not gate. When you give it 0, it gives you back 1, and when you give it 1, it gives you back 0. Think of not gate as a rebel kid who doesn't listen to others at all. They do the opposite of what is said. Or we can say inverse of what is said. The not gate does the same. The logical definition of not gate is the gate which inverts the input. Therefore, NOT gate is also called as inverter. The symbol of NOT gate has a right-facing triangle and a small circle called inversion bubble at the output tip to indicate the inverse or opposite. As usual, the input is at left and output is at right. Do you know? NOT gate is the only gate that doesn't have multiple inputs. Let's get inside the NOT gate. Inverter is usually made up of CMOS circuit, a combination of NMOS and PMOS. We have input, output, drain voltage VDD at PMOS, and grounding at NMOS. I hope you are familiar that NMOS turns on when gate voltage is 1, and PMOS turns on when gate voltage is 0. Remember, we use only 0 and 1 in digital electronics. Let's say initially both the MOSFETs are off. When we give 0 as the input to the CMOS circuit, NMOS stays off and PMOS turns on. Since PMOS is connected to drain voltage, it pulls the output voltage up to VDD, which has certain value higher than 0, but not 0, which means the output is 1. Because in digital electronics, any value other than 0 or higher than 0 is considered as 1. Let's represent it through the waveform. Inputs and outputs are shown using separate waveforms. The waveforms will have 2 levels, one for lower and one for higher level. We are giving 0 as input and got 1 as output. If we change the input to 1 this time, then NMOS turns on and PMOS turns off. NMOS is connected to ground, so it pulls the output to 0 as well. In timing diagram, we are giving 1 as input and got output 0. Since we don't have any more digits to check the working, we can write the truth table. 1 input column. Because we have only 1 input for NOT gate and 1 output column. When input is 0, the output is 1, and when input is 1, the output is 0. Let's see some relatable examples of NOT gate, or more like real-life examples, which have a NOT gate methodology. We all know how security alarms work. If it's for a door, the alarm won't turn on while the door is closed. But if it's left open for longer time, or when opened forcefully, the alarm will start buzzing. The sensors at the door gives input and alarms are the output. Let's say the sensors produces 1 or high signal as long as the door is closed. Pass it through the NOT gate, the output will be low signal or 0, which keeps the alarm off. But when the door is forcefully opened, the sensors produce lower signal. The output will be high signal or 1, which turns on the alarm. Another example is automatic lights. When it's daytime, lights will stay off, but when it's night, the lights will automatically switch on. And how can you forget the curiosity game of childhood? The light of refrigerator. It has the same logic as well. When the door is closed, the lights are off. When the door is opened, the lights are on. Let's move on to pros and cons of NOT gate. First of all, they work as switches, pulling between 0 and 1, which makes them to serve as basic fundamental block in many circuits. NOT gates are of small size. They need only 2 transistors. so they are easy to implement or integrate in any circuit. A single NOT gate will be low-cost consuming, less power consuming. But the disadvantage is that their function is only negation or inversion, and they are in almost all of the complex circuits. So multiple NOT gates have to be implemented, which will affect the power consumption of the whole circuit, occupies more space and introduces more delay. But nevertheless, NOT gate, also called as inverters, are very much loved and used in wide range of applications. This is it for today. We are going to talk about AND gate in the next class. See you there. Don't forget to like, share, and subscribe.